Okay, we're going to review a couple of things here, and then we're going to look at example 4 and example 5 together. Keep in mind that this standard is I can solve quadratics by factoring. So when you solve quadratics by factoring, you have to do the whole factoring process, which we were working on yesterday and we're working on again today. But then there's this final step that we haven't really talked about, the actual solving part. So like, for example, 2 and 3, we, on the first video, worked through factoring, getting the parts that make up the whole. And one of the applications of factoring is that you're able to solve this quadratic very quickly once you get to this point. And when you solve a quadratic, you're trying to find the place where it crosses the x-axis, or where y is 0. So let's go back to this. Alright, so factoring and solving a quadratic. To solve a quadratic, we are looking to see where this is equal to 0, or the places where it crosses the x-axis. So I have to start by subtracting 5 from both sides. I'm sorry, this should be a negative 18. Okay. And then we're going to factor this just like we did on the previous page. So you first look to see if there's a greatest common factor. There's no greatest common factor here because there's no number besides 1 that goes into 8, 18, and 5. So I'm going to pull out, or I'm not going to pull out anything at this point. I'm going to start by factoring or multiplying 8 and negative 5 together to get negative 40. Then I'm looking for two numbers that multiply to get negative 40 and add to get negative 18. Alright, so we've talked about, because I know this is difficult for some of us, two numbers that multiply to get negative 40 and add to get negative 18. In order to multiply to get a negative number, you need one of your numbers to be negative. So we know that's going to be the case. And 18, that means that my two numbers, the space between them has to be 18 in order to subtract them to get negative 18. So I'm going to start with negative 40. I'm going to divide by 2. So 2 and 20. Now the reason I divided by 2 is because this is an even number, so I just wanted somewhere to start. And so I divided by 2. 2 and negative 20, or negative 20 and 2, either one, the space between them is a space of 18 units. And then if I make the 20 the negative value, if I add them together, I get negative 18. Once you find those two numbers, you're going to replace the middle term. Doesn't matter what number goes first. Notice I'm keeping the equal 0 because that's reminding me that at the end here I have to solve. Now I'm going to factor by grouping. So I group the first two, group the last two. In the first grouping, I can pull out a 4x. I'm left with 2x minus 5. In the second grouping, I can pull out a 1. I'm left with 2x minus 5. Now my final factorization are the greatest common factors put together, so 4x plus 1, and then the 2x minus 5. Now, in the other problems that we've been working on, I had to stop here, but now that there's an equal sign, I have to go further. In order to solve this, or in order for this equation to be true, either this has to equal 0, because then 0 times anything will be 0, or this has to equal 0, for the same reason. That's why we factor, because then you have two units that if either one equals 0, you've solved the equation and gotten your answer. Graphically, what these two values will be when we solve it are the places where y is 0 in the graph, or the places anywhere on the x-axis. So we, at this point, set each factor equal to 0. Now in solve, here I'd subtract the 1 over and divide. Here I'd add the 5 and divide. So negative 1/4 and 5 halves. These are my x-intercepts. So if I was to graph this function, this original function, it's in standard form, so I'd have to, do the negative b over 2a, make the table, graph. But it would cross the x-axis at those 2 points that we have found. Okay, let's do another one. Let's go with 3x squared minus 42x plus 147. Oh, you know what? I've already done that one with you guys. Sorry. I just realized I picked the same one. Let's do 4x squared plus 10x equals x squared plus x plus 4. And actually, sorry, that should be a minus. Okay. In order to solve this, because notice we have an equal sign, that means I'm going to have to end up getting two answers like I did here. You first have to move everything over to one side and get it equal to 0. So I'm going to subtract the x squareds from both sides. So we get 3x squared because 4 minus 1 gives me 3x squared. I'm going to add x to get 11x, and then I'm going to subtract 4. So again, if you need to write yourself a note there, whenever there's an equal sign, in order to factor and solve, you have to get everything over to one side and get it equal to 0. Okay, then we're going to multiply a and c together to start the factoring process. Negative 12 is what a times c equals there. The two numbers that multiply to get negative 12 and add to get 11 would be 12 and negative 1. So I'm going to take those two numbers and replace the middle term. So we get 3x squared plus 12x minus x minus 4 equals 0. Then I'm going to factor by grouping. So I'm going to group the first two, group the last two. Out of the first grouping, I can pull out a 3x, and I'm left with x plus 4. Out of the second grouping, I can pull out a 1, but because this term is negative, you also want to pull out a negative. And when you pull out a negative, it changes the signs. Because remember, these have to be the same. So your final answer is 3x minus 1, or sorry, your final factorization is 3x minus 1 times x plus 4 equals 0. Now, if I was to solve this, because of that equals 0, now I take each factor and actually set it equal to 0. So here, my x would be 1/3, and here my x would be negative 4. And those would be my two answers, or the two places where my graph, if I graphed it, would cross the x-axis. Excuse me. Okay, the final thing we're talking about today is the difference of squares pattern. Difference of squares factoring pattern says if you have two values and you're subtracting them, and it's basically something that can be squared for both of them. When you factor, both parentheses are going to end up being the exact same things, just one positive and one negative. The reason we're talking about this is because this pattern is so frequent that we need to make sure that you can recognize it pretty fast. And we're going to factor and solve all of these. Okay, so here's the first one. I notice I have two terms. I have a quadratic, so I can probably factor it. I have two terms and I'm subtracting. If we can take the square root of both those terms, then it fits this pattern. So the square root of x squared is x, so my a, or what's being squared, is x. What's being squared to get 4, or what the square root of 4 is 2. So then I plug what a and b are into the pattern. The pattern here is x minus 2 times x plus 2. And then if I was to solve, you'd set x minus 2 equal to 0, x plus 2 equal to 0. So you get 2 or negative 2 as your answers. Now, the reason this works is because if we FOIL this back together, your first terms would give you x squared, your outer would give you 2x, the inner would give you negative 2x. Your outer and inner would cancel, because notice we don't have an x term, and then negative 2 times 2 would give me that negative 4. So that's why this pattern always ends up working this way. Let's look at 9x squared minus 49. Okay, two terms, I'm subtracting, I have a quadratic, so let's try to factor it. If it fits the difference of squares pattern, you should be able to factor out, or not, sorry, factor out. You should be able to take the square root of both these terms. Square root of 9x squared, I can take the square root of that, it's 3x. Square root of 49 is 7. So my factorization will be 3x plus 7, 3x minus 7. And if I was to set both those equal to 0, you'd get plus or minus 7/3. Because you get the same value, just one's positive and one's negative as your answers. Now, you might want to write yourself a little note. So you remember, if you need to. Okay. You don't worry about the negative when you take the square root because the pattern takes care of the negative for you. And then last one, let's go with 64x squared minus 100. Now, you have to, like, we could factor this like we were doing up here, if you wanted to, because what would happen is you would just say, okay, they have to add, have to multiply to get 6,400, which is what that would be, and they have to add to get 0 because you're missing the middle term. But if you recognize that, hey, I can take the square root of 64x squared, that's 8x, and hey, I can take the square root of 100, that's 10, then it becomes a very quick factoring problem if you recognize that that happens. And you get answers here of plus or minus 10/8, or plus or minus, you could reduce that to 5/4. Yeah, so that's the difference of squares pattern. Alright, and that's where I'm going to stop for today. And with these 4 type problems, I'll probably post the video on Wednesday, but we might not talk about it until Friday because I want to make sure that we've got this under our belt before then. So, yeah, come ready tomorrow to practice factoring and solving, and we'll just try to do as many problems as we can in the time that I have you in class so that you get a chance to ask questions.